Good afternoon, everyone. Welcome back. Last time we were talking about differential equations and differential calculus, and now we are going to talk about integration. Okay, so we talked about differentiation and now integration. They go hand in hand. So if you've done your differentiation well, then you will be able to do integration also well. In differentiation, we were talking about rate of change. Okay, so we talked about how to find the gradient. Okay, so we talked about dy dx. So when there is a small change in the independent variable, what is the change happening in our function? That is what we talked about in the differentiation. The opposite of that we are going to talk about is integration. Now, you know the word integration. We just celebrated our Republic Day, so we talked about integration of so many languages, so many cultures that are there in India, right? So, in integration, what happens? We bring together many things. So, similarly, here in integration and mathematics, we are bringing together. And how do we do it? We are going to see that if I know my formula for differentiation, the formula for integration becomes easier for me to understand. So we talked in differentiation, we talked about to express the rate of change in any function, we say that a very small change in the dependent variable with reference to a very small change in the independent variable. That is what we talked about. Then we say that differentiation is the process of finding the derivative of a continuous function. It is defined as a limiting change. That's why we found out limit extending to delta extending to 0, right? Of the ratio of change in the function corresponding to a small change, which is also called as increment in the independent variable or called as argument, as the latter tends to 0. Okay, so that's what we did. We said limit, isn't it? In the formula we said limit delta x tending to 0, right? So this is what we did in derivative. Now we are saying that integration is the reverse process of differentiation. So integration, so if I have fx as the function, if I want to find the derivative, differentiate, I get f dash x. And if I integrate the f dash x, I should get fx. Okay, just let me repeat. If I have a function fx, if I find its differentiation, I will get f dash x. And if I integrate this f dash x, I should get my fx. Okay. So you remember this formula for differentiation? I'm just revising it. D by dx of x raised to n is n, x raised to n minus 1. So what happened in derivative is the power, that is x raised to n. So n is the power. When I differentiate, it becomes x raised to n minus 1, right? So the power is decreasing. E raised to x remains as it is. A raised to x is a raised to x into log a. And we know the derivative of a constant is 0. This is very important while understanding integration, is because in the integration formula, we always have plus c. This is because if in my original function, I have a function, say maybe, let me say, I have a function x square plus 3x plus 2. If I differentiate this, I will get 3x plus 2x plus 3, right? But when I integrate this, what will happen is, because this differentiation of 2 is 0, because I'm using this formula 4, I have to use plus c in my integration formula. Okay, so you appreciate this c in my integration. This is because when I differentiate, I will not have the figure 2 here, because derivative of a constant is 0. Okay, and so when I want to integrate this, I should be able to get the original fx, and so I add plus c. Then d by dx of ax is a into e raised to ax. D by dx of log x is 1 upon x. Okay. Now we come to integration. See. If I know my derivative formula, I will be able to have my integration formula. Now we said here, we say the integration of x raised to n is x raised to n plus 1. Can you appreciate this? In derivative, what happened was d by dx of x raised to n is n into x raised to n minus 1, right? But here what is happening in integration? The power is increasing. So it is x raised to n plus 1 divided by n plus 1. So here we had multiplication n into x raised to n minus 1. Here we have x raised to n plus 1 upon n plus 1. Okay. But in this formula, remember that n can never be equal to minus 1, because if n is equal to minus 1, what will happen in the denominator? We will have the condition 1 upon 0, because minus 1 plus 1 will become 0, and 1 upon 0 is infinite, or which is not defined. Okay. So that is why here in this formula, you always remember that n can never be equal to minus 1. So the first formula that we are doing is integration of x raised to n dx. Integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Okay, where c is a constant. Now integration of dx. So what happens is integration of 1 dx. Integration of dx means integration of 1 dx, which is equal to integration. Instead of 1, remember in indices we have written that x raised to 0 is 1. We know that x raised to 0 is 1. So instead of 1, I am writing x raised to 0. X raised to 0 dx is equal to, now what is the formula? X raised to n plus 1 upon n plus 1. So I will write x raised to 0 plus 1 upon 0 plus 1 plus c. So what is x raised to 0 plus 1 is x raised to 1. So it is x raised to 1 upon 0 plus 1 in the denominator is 1 plus c. I know I don't have to write the 1. So this is simply x plus c. Okay. So I have shown you the derivation also of the formula. Integration of 1 dx is equal to x plus c. Integration of e raised to x dx is equal to e raised to x. Because derivative of e raised to x is e raised to x, so we have integration of e raised to x is also equal to e raised to x. You don't have to learn the derivatives. What I want you to understand is that once I know the derivative formula, even if in case I don't remember my integration formula, using my derivative formula, I can go and use form the integration formula. I hope you are understanding up till now. Yes, Jaspreet, Harshita, Harsh, Shambhavi, Dhairya. Good afternoon. Yeah, good, you understood. And thank you for appreciating last time's doubt solving session. I'm very happy that all of you understood all the sums that I had taken and you really appreciated them. Thank you so much. Right? So here we have done the formula. First formula that we have talked about is x raised to n. Second formula we talked about is integral of 1 dx. Third formula is integral ex dx is equal to e raised to x plus c. Okay. Now I have the formula integration of e raised to ax. Okay, e raised to ax. Remember derivative of e raised to ax. Okay, d by dx of e raised to ax is equal to a e raised to ax, right? So a into e raised to ax. So here we say integration of e raised to ax dx is e raised to ax upon a plus c. So this is the fourth formula we are using. Fifth formula is saying that 1 upon x. Suppose I have 1 upon x dx, this is equal to log x plus c. See, this in some books you will find it written like this. So integration of dx upon x means the same as integration of 1 upon x dx. Okay. Some children get confused. Let me put that to rest. Writing dx upon x or writing integration of 1 upon x into dx is one and the same thing. So what is the formula for that? This is equal to log x plus c. From where did this come? This came because I know that d by dx of log x is 1 upon x. So sixth formula that we are taking up is a raised to ax. Integral of a raised to x dx is equal to a raised to x upon log a to the base e plus c. Because I know d by dx of a raised to x is a raised to x log a to the base e. Okay. So integration of a raised to x dx is a raised to x upon log of a to the base e plus c. Okay. So these are the basic 6 formula that we are using. Then later on we have more formula. We have formula for integration of 1 upon x square minus a square. Then we have formula for under root of x square minus a square. You know, all those special formula are there. But the basic formulas are these which we are going to use. So let us go to the sums. Remember that in integration there will be some sums which will be directly based on the formula. In certain sums, what will happen? we will be using integration by parts. Then the third type is integration by substitution. So when I'm using substitution, then partial method, okay. Then you can even have like just doing by simple arithmetic, you know, we will be using that. Then we have to talk also about islet, which though you will not be needing in full, but you must know this, that when we are doing using integration of u into v, then this rule is applicable. Okay. So let us go one by one. Let us go first solving sums in which we are using the basic, this 6 formulas that we have talked about right now. Okay. Okay. So the first question we are taking is this: integration of under root of x dx. So as we wrote in derivative also, similarly here we are going to use the basics of indices. Yes, co-major. We will be taking up log x also. Okay, right. Yes, Jaspreet, there are a lot of use of integration in practical life. We are using it to find area under the curve. In physics also, we are using it to find derive the formulas in physics. Okay, where you are finding out densities and you know, there are a lot of complicated things in physics also that use this thing. And for us also in finance, we are using a lot of integration. Okay. So it is a very practical thing that is very much needed. So let us now go to integration of root x. As I told you that remember your formula that square root of x in indices can be written as x raised to half. Square root of x can be written as x raised to half. Then cube root of x can be written as x raised to 1 by 3. And nth root of x can be written as x raised to 1 upon n. Okay. The second thing you must remember is 1 upon x can be written as x raised to minus 1. 1 upon x raised to n can be written as x raised to minus n. Okay. All these things you must remember. Remember, x raised to 0 is 1. So, using all this basic knowledge, let us talk about integral. Integral is written as a elongated s square root of x dx. Okay, square root of x dx. Just let me thicken this. So this is equal to x raised to, so instead of root x, I'm going to write down as x raised to half. So this is what integral of x raised to half dx. Which formula am I using? Integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1. Okay, so I've just written the formula also for you so that it is there in your memory. So whenever you have this type of sum, you must remember that madam had written the formula over there. Okay, so which formula is it? Integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So what is my n here? So n is equal to half, right? This is my n. So what will happen? This therefore integral of x raised to half dx, x raised to half dx is equal to x raised to half plus 1 upon half plus 1 plus c. Okay, which is equal to x raised to half plus 1 is how much? 3 by 2. Okay, half plus 1 is equal to 3 by 2 upon 3 by 2 plus c. Remember, whenever I have a fraction in the denominator, it will flip. So this will become 2 by 3 x raised to 3 by 2 plus c. Okay, so you may have it in this manner, or you may have it as written as 2 by 3 x root x plus c. Okay, so you must know this. You must know that x raised to 3 by 2 can be written as x root x. Okay, I will just show it to you for one example so that the concept is very clear. You must have done it in the chapter on indices, but this is just for your revision. Okay. See, whenever I have x raised to 3 by 2, this can be written as x into x raised to half. 3 by 2 can be written as 1. See, 3 by 2 can be written as equal to 1 plus half, right? 1 plus half is 2 plus 1 upon 2, which is equal to 3 by 2, right? So, x into x raised to half. So, in place of x raised to half, I can write it as x into root x, right? Using this. And so, either in the option you may have it this way, or in the option you may have it this way. Or you may even have it as x raised to 3 by 2 upon 3 by 2 plus c. Okay. So, either of these options you may have. Right? I hope you've understood. Just put it whether, because once these concepts are clear, we can go ahead. Yeah. Good. Okay, Khomeja, right, no problem. Yes, Shiba. Yeah, very good, very good. Chandan, Priyanka, excellent work. Okay, right. So, can you now do on your own this next one, right? The next sum is x raised to 1 upon root x dx. Okay, right now I told you how we are going to write it. 1 upon x can be written as x raised to minus 1. 1 upon x raised to n can be written as x raised to minus n. So we are going to use this concept and we are going to solve this. So first thing we are going to do is, let me get back to the blue color. So I'm just telling you that 1 upon root x can be written as 1 upon x raised to half, which is written as x raised to minus 1 by 2. This is the only step where student gets confused. Otherwise, so many of you know all the formula for integration. You have taken a lot of effort, but you miss out on this. This you must remember. Okay, so now let us use this. So integration of 1 upon root x dx is equal to integration of x raised to minus half dx. Now, which means that n is equal to minus 1 by 2. So this is equal to, what is the integration? X raised to n plus 1. So minus half plus 1 upon minus half plus 1 plus c. X raised to minus half plus 1 is x raised to half. Okay. What is minus half plus 1? Plus half. You have got one chapati, and if you eat half of it, what will remain? You will have plus half chapati. Okay. So it's just as simple as that. So this is equal to 1 half plus c. Now this can be written as what? Root of x. And the fraction in the denominator will be flipped. So it will be into half plus c into 2 plus, sorry. It will get flipped. Okay, so it will become 2 upon 1. So this is equal to 2 root x plus c. Is that clear? Okay. So this is the way you have to solve it. If you solve the initial sums very carefully, you will not have any problem. Now you have integral of e raised to minus 3x dx. Okay. So which formula am I using? Integration of e raised to ax dx is equal to integration of a raised to x e raised to ax upon a plus c. So integration of e raised to ax is equal to e raised to ax upon a plus c. So here what is happening? How much is my a? A is equal to minus 3. Okay, just remember a is equal to minus 3. So integration of e raised to minus 3x dx is equal to e raised to minus 3x upon a. A is how much? Minus 3 plus c. This minus sign can be written together. This is minus e raised to minus 3x upon 3 plus c. Okay. Next sum we are doing is integration of e raised to x integration of 3 raised to x dx. Okay. So which formula am I using here? I am using the formula integration of a raised to x dx plus a raised to x dx is equal to a raised to x upon log a to the base e plus c. So here what do I have? A is how much? 3, right? A is how much? 3. So integration of 3 raised to x dx is equal to e raised to 3 raised to x upon log of 3 to the base e. Okay. Integration of 3 raised to x dx is equal to 3 raised to x upon log 3 to the base e plus c. Okay. So can you see, can you appreciate that? These are, if I know my formula well, these sums I can do in a matter of 30 seconds, right? So I will be able to save time a lot, because if the direct sums come, if I know all the formula, so you can see it can be done easily. I must just know what is my n, what is my a, and I can solve them. Now integration of x root x dx. See, I just showed you. Why I showed you that earlier? Now you will be able to appreciate this. See here. 3x raised to 3 by 2 can be written as x square root of x into square root of x. Here I have shown you the whole calculation, or everything written in orange. This we will be using in the sum that we are going to take up now. Okay, I hope you've understood till now. Please don't be afraid of the chapter, okay? There is nothing to be afraid of. Yes, Shiba, Chandan, Priyanka. Priyanka, it is plus C, okay? You forgot to put the plus sign. Good, Shambhavi, you understood. Mohammed. Great, great. Dipanshi Chandan, right. Now let us go to this. Now the sum says, which formula am I going to use? Integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Now the problem is I have x here also, x here also. So I'm writing the x into root x. This is equal to x raised to 1. Instead of root x, I'm writing it right, x raised to half. Now I know indices formula a raised to m into a raised to n is equal to a raised to m plus n. Okay. So I have this to be equal to x raised to 1 plus half, which is equal to x raised to 3 by 2. So my integral x root x dx is equal to integral of x raised to 3 by 2 dx. Now, what is my n here? N will be equal to 3 by 2. So, this will become x raised to 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. Okay. This is equal to x raised to 3 by 2 plus 1 is what? 5 by 2. X raised to 5 by 2 upon 5 by 2 plus c. Which is equal to the fraction in the denominator will flip. So I will have 2 by 5 x raised to 5 by 2 plus c will be my answer. Okay. Now let us go to the next sum. X plus 1 upon x whole square. Now here what do we have is in integration it is if I have something square or cube, it is better that I expand it and then find the integration of the individual terms rather than trying to do it together. Okay, so here what do I have? I have x plus 1 upon x the whole square, right? This is what, this is the integration I want to find out. Okay. So, what is the formula? This is, which formula I am using? A plus b whole square. A plus b whole square is a square plus 2ab plus b square, right? All of us know this. So using this formula, what do I have? X square plus 2 into x into 1 upon x plus 1 upon x the whole square. So this is equal to x square. This x and this x will get cancelled. So plus 2 plus 1 upon x square. Okay, so instead of writing this, I'm going to write this as integration of x plus 1 upon x the whole square dx to be equal to integration of x square plus 2 plus 1 upon x square dx. Okay, this can be written as this is equal to integration of x square dx. Okay, the rule says for if I have addition of terms in the under the integration, it will be equal to integration of each individual terms added. Okay, and same thing for subtraction also. So x square dx plus 2 integral of 1 dx plus integral of 1 upon x square dx. Which formula am I going to use? Integral of x raised to n is equal to x raised to n plus 1 upon n plus 1. So this will give me what? X raised to 3. 2 plus 1 is 3 upon 3 plus integral of 1 dx is what? X. So this becomes 2x. And integral of 1 upon x square is equal to what? X raised to minus 2 plus 1. So this becomes x raised to minus 1 upon minus 1 plus c. Okay. So minus 2 plus 1 is minus 1. So this becomes this. This is equal to x cube upon 3 plus 2x. X raised to minus 1 can be written as 1 upon x with the minus sign. So minus 1 upon x plus c. There is a minus sign here. I hope you can see this minus sign. Else I will write it again. This is equal to minus 1 upon x plus c. Okay. What have we done here? I had a square. Okay. I had a function whose square was there and I had to find the integration of that. So what I did was I expanded. I used a plus b whole square. I expanded and then I found the integration of individual terms and then I added them. And write down plus c in the end. Right? Hope you've understood. Okay. Yes, Chandan. When you have e raised to minus 3x, it will be e raised to minus 3x upon minus 3. But when you have 3 raised to x, it will be 3 raised to x upon log of 3. Okay. So, as I told you in derivative also, if it is e raised to something, then it becomes e raised to 3x, it will be 3 into e raised to 3x. When it is 3 raised to x, it becomes the log factor will come into play, right? Very good. Priyanka, where was 1 upon x? Where did we find 1 upon x? Just a minute. This fifth one, where? We did not have integral of 1 upon x here, Priyanka. It is 1 upon root x. Okay. So if I have integral of 1 upon x, I can use it as log x, right? Okay. This formula that you're talking about. Okay. This fifth formula we are talking about is integral of 1 upon x. And in the sum, we have integral of 1 upon root x. Okay, in this formula, we have question, we have 1 upon root x. And if you are talking of this sum, then what happens is this is not only this is whole square. Okay, appreciate that. It's good that you pointed out. Some others may have also have the same problem. Here it is not simply 1 upon x. This is x plus 1 upon x the whole square. Okay, I've shown you over here. Okay, this is x plus 1 upon x the whole square. So that is why we cannot use it that way. Had it been simply 1 upon x dx, then I would have used log x, right? Hope you've understood, Priyanka. Now this is an interesting sum. Okay. As I was telling you that we have to simplify it. Now here there are two terms. We have the formula of integration by parts, but as far as possible, we don't want to go into that complicated thing. We would like to use it as simply as possible. Okay, so for that we will expand and then we will integrate individual terms and add and subtract whatever the requirement of the sum is. Now root x can be written as x raised to half. Root x can be written as x raised to half. So this is equal to integration of x raised to half into x cube plus 2x minus 3 dx. Now I am going to expand. So for each terms inside the bracket, I am going to multiply by x raised to half. So this is equal to integral of x raised to 3 plus half. X raised to 3 plus half is 7 by 2 dx plus 2 integral of x into x raised to half will be x raised to 3 by 2 dx minus 3 integral of 1 dx. Now which formula will I use? Integral of x raised to n is equal x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So how much will this be in this part? N is 7 by 2. So this will be 7 by 2 plus 1 will be x raised to 9 by 2 upon 9 by 2 plus 2 into x raised to 3 by 2 plus 1 will be 5 by 2 x raised to 5 by 2 upon 5 by 2 plus 3 integral of 1 dx is x, so it will be x plus c. Now I need to just flip the denominator. So what will I get over here? This is equal to 2 by 9 x raised to 9 by 2 plus 4 by 5. How did the 4 come? Because 5 by 2 when it flips it becomes 2 by 5 and 2 into 2 is 4. So this is x raised to 5 by 2 plus 3x plus c. Okay. Oh, I forgot to multiply here. This is equal to this is not. This is integral of, see, I multiplied this root x into 3 by 2, root x into 2x, root x into, so this will be x3 to half integral dx. Okay. Integral of x raised to half will be what? X raised to half plus 1. So this will be x raised to 3 by 2 upon 3 by 2. So I will have 3 into 2 by 3. The denominator will flip into x raised to 3 by 2 plus c. This 3 and this 3 will get cancelled. I will have 2 x raised to 3 by 2. So this will be the answer. So this is equal to 2 by 9 x raised to 9 by 2 plus 4 by 5 x raised to 5 by 2 plus 2x raised to 3 by 2 plus c. Okay. Here I have to multiply each x raised to half with this. I have to multiply it with this and I have to multiply it with this. Okay. So every term inside the bracket gets multiplied by root x, right? Okay. So now we are using this. What is integral of e raised to ax dx is equal to e raised to ax upon a plus c, right? In the formula that you have written, you can see fourth formula, e raised to ax dx is equal to e raised to ax upon a plus c. So we are using this formula. Now this integral of e raised to 3x plus e raised to minus 4x dx is equal to integral of e raised to 3x dx plus integral of e raised to minus 4x dx. What is the value of a in this term? A here, a is 3. What is the value of a here? A is equal to minus 4. So integral first will become what? It will be e raised to 3x upon 3. And here it will be e raised to minus 4x upon minus 4 plus c. So in the option you will find the answer as e raised to 3x upon 3 minus e raised to minus 4x upon 4 plus c. Okay. So this is the way you should do it. Where do you want minus sign? No, that is plus. Okay, so there is no minus sign over there, right? Okay, now let us. No, I don't think so. But if still you want, just write it to me. Which line you are talking about? I will just check. Okay. Yes, Vecha Varshini. Yes. Okay. So you can just let me know where you want the minus sign. Maybe I have skipped somewhere. Okay. Now for this sum, x square upon x plus 1. Whenever the power in the numerator is more than the power in the denominator. So here you can see the power of x is how much? 2. And what is the power of x here? 1. So I can go in for the division method. So I can actually divide the numerator and the denominator with the denominator, and then I will integrate. Okay. Or I may rearrange it also. Okay, so you can do it by both this method. I will show you by both the methods, so you can use it whichever method you are more comfortable with. If you remember how we used to do division in school, so if I want to divide x square by x plus 1, so x will go x times x into x will give me x square, and x into plus 1 will give me plus x. And then I subtract, so this become minus minus, so plus x square minus x square will get cancelled, so it will be minus x and then plus 1. Now if I want this minus x, with what should I multiply this x? I should multiply it by minus 1. Minus 1 plus x will give me minus x, and minus 1 plus 1 will give me minus 1. Again I subtract, so this minus becomes plus, this minus becomes plus. This minus x, this plus x will get cancelled, is left with 1. So when I divide x square with x plus 1, x square upon x plus 1, what is left in the numerator? It is x plus 1. And what is the remainder? Remainder is 1. Remainder upon the divisor. So this is 1 plus x plus 1. Okay. So I do the actual division. I take the x term in x square, I divide it with the term in the denominator, which is x plus 1. This is possible only when the power in the numerator is more in the denominator. So instead of this, I can write it like this. Okay. And then when I integrate, so integral of x square upon x plus 1 dx is equal to, I can write this is equal to integration of x plus 1 dx plus integral of 1 upon x plus 1 dx. Now what will be the integration of this? This is equal to integral of x dx plus integral of 1 dx plus integral of 1 upon x plus 1 dx. How much is integral of x dx? It will be x raised to 2, 1 plus 1 upon 2. Integral of 1 dx is x, and what will be the integral of this? It will be log of x plus 1 plus c, because integral of 1 upon x is log x dx, and here it is an integration of 1 upon x plus 1, so it will be log of x plus 1. Okay, so this is the method where I have done the actual division. Okay, I've done the actual. Now if you are comfortable, you can also use this method. Okay, because I can see x plus 1 in the denominator, I am going to write the numerator in terms of the denominator. So what do I do? And this you can get by practice. Okay, don't feel कि अरे मेरे को अभी नहीं आ रहा, मैं क्या करूं, ये ऐसे बुक में ऐसे कैसे दे दिया. आप 4 क्वेश्चंस कीजिए, आपको अपने आप से आने लग जाएगा. Okay, so there is nothing to worry if you don't, it doesn't strike you in the first instance. The more you practice these sums, automatically you will start thinking of how to rearrange the numerator so that my denominator gets cancelled. Okay, so or the question becomes simple. This is x square. So in the denominator I have x plus 1. So what do? I say x square minus 1 plus 1. Can I write like this? Yes, because I'm subtracting and adding the same number. So that means I'm not doing any changes. I'm just writing x square minus 1 plus 1. Minus 1 plus 1 is what? 0. So numerator remains as it is. This is just a rearrangement. Now x square minus 1. Do you remember a square minus b square can be written as a plus b into a minus b. Okay, a plus b into a minus b. Same thing I'm going to do here for x square minus 1. So what I do, I write this as x square minus 1 plus 1. So I just put that in a bracket and upon x plus 1 dx. Now what I do, I write this as integral of x square minus 1 upon x plus 1 dx plus integral of 1 upon x plus 1 dx. Okay. So dx upon 1x plus 1. Is it clear? Now here instead of x square minus 1, what do I write? A plus b into a minus b. So this can be written as integral of x plus 1 into x minus 1 upon x plus 1 dx plus integral of dx upon x plus 1. Okay? Now this x plus 1, okay, this x plus 1 will cancel with this x plus 1, right? So what am I left with? I am left with this is equal to integral of x minus 1 dx plus integral of dx upon x plus 1. Now what is integral of x minus 1? It is equal to integral of x dx minus integral of 1 dx plus integral of dx upon x plus 1, which is going to give me x square upon 2. X integral of x is x square upon 2. Integral of 1 is x. So this is minus x. And what is integral of 1 upon x plus 1? It is log x plus 1 plus c. Can you appreciate that? Plus. Can you appreciate that? Oh no, this is minus only. I don't know why I'm making mistake with the sign. Okay, so this is minus integral of 1 dx and this is minus x dx. Only here what had happened is numerator, this is here. Okay, this becomes this is minus. Okay, here because the when I divide, so what do I have here? So this is x minus 1. So here I have this is x minus 1 and here also. Okay, sorry for the mistake in sign. So this becomes x minus 1. This is integral of 1 dx. So this becomes minus x. Okay, because see what is happening when I divide x square by x plus 1, I get x minus 1 as the quotient. So this is x minus 1 plus remainder is 1 upon x plus 1. So can you see that this answer and this answer are one and the same? Okay, so do it in whichever method. Do actual division, you will get the same answer. If you can do this step is very important. Minus 1 plus 1. Okay, this step if you are able to make out, then that is the best thing that you can do. Okay, so either way you are going to get the same answer, and just be careful with the signs. Don't make the mistake that I did. Okay, just keep it over here. Just let me check whether all of you have understood this or not. Okay, yes, Shiba, I'll explain again. The remainder is not to Vidya, sorry, Vidya. Okay. Minus 1 plus 1 is Okay. Yes. So now let us go to the next part. Next sum here. So here also we are going to do it the same way. Okay. So we can actually find the division here, right? So can you just tell me what will be the answer for when I divide it by actual division? Yes. Let us do it over here. Okay. X cube plus 5x square minus 3. When I want to divide this by x plus 2. Now for x cube, what should I multiply x with? I should multiply it by x square. Okay, I should multiply it by x square. X square into x is x cube. X square into 2 is plus 2x square, right? Now when I subtract, it becomes minus and this becomes minus. This cancels out. What will I be left with is 3x square minus 3. Now 3x square I want over here. So I must multiply it by 3x. 3x into x will give me 3x square. So this is 3x square. 3x into plus 2 will give me plus 6x. Okay, I can't write it below minus 3. Why? Because this the term is 6x. So the term is in x. So this is minus and this minus. I am left with this minus 6x minus 3. Now minus 6x, if I want, I must multiply x with minus 6. So minus 6 into 6 will give me minus 6x. Minus 6 into plus 2 will give me minus 12. So this becomes plus, this becomes plus. I am left with this 9. Okay, minus 12 plus, so plus 12 minus 3 will give me 9. So what will I get? This integration is equal to integration of x square plus 3x minus 6 dx plus integration of the remainder is 9 upon x plus 2 dx. Okay. So what will I be left with? What will happen when I want to integrate this? This is equal to integration of x square dx plus 3 into integration of x dx minus 6 into integration of 1 dx plus integration of 9x plus 2 dx. So what will happen? This is equal to x cube upon 3, right? X square integration will be x raised to n plus 1 upon n plus 1. This will be 3 x square upon 2. X integration of x is x square upon 2 minus 6 integration of 1 will be minus 6x plus 9 into log of x plus 2, right? Integral of 1 upon x plus 2 is log of x plus 2 plus c. Okay, so this will be my integration, right? Okay, Vidya, just let me just check and let me get back. Right? So this will be the answer. Yes. Very good, Shivam. You've understood the second method also. Excellent work. Excellent work. Okay. Because here the division method becomes easier, so I've used the division method. If I have got quadratic, I can even try and find out. Or quadratic, I can try to make it into I can find the factors and then I can divide. So whichever method is clearer to you, use that method. Okay. So just check on this. Right? Okay. So it is 3 o'clock. Let us take a break for 5 minutes, right? Let us take a break for 5 minutes and we will come back, and it's 3. So we'll come back at 5 minutes past 3. Okay. Okay, so some of you got a bit confusion. There is some confusion with the division method. So let me redo it for you. See, I have x square here and it is to be divided by x plus 1. Now, if I want x square, so I should multiply x with what to get me x square? X into x will give me x square. So I multiplied here with x. X into x gives me x square. X into plus 1 will give me plus x, right? When I subtract them, what will happen? This x square and this x square will get cancelled. I am left with minus x, okay, minus x. Now with this minus x, I bring in this plus 1 down. Now minus x, I want x. So this will be x minus 1. So when I multiply minus 1 with x, I will get minus x. When I multiply minus 1 with plus 1, I will get minus 1. So this becomes minus x and minus 1. Okay. And so when this happens, minus x plus x, this will become plus and this will also become plus. This will get cancelled and I will be left here. Okay. So this is the way we have to do it. Now let us go to the next sum. You've done this. Now we have the method called as method of substitution. Like we did for derivative also, we have to use the same method. Okay. So we will be using that. Okay. Okay. See here. I now understood why you people are getting confused. This remainder is minus x. So minus 1 into x will give me minus 1. And minus 1 into plus 1 will give me minus 1. Okay. I had just written over here plus 1. Why? For you to understand that I have to subtract this. So minus x plus x will give me 0. And what will be the remainder? Plus 1. So when I am dividing x square upon x plus 1, what do I get? I get in the quotient as x minus 1. And what is my remainder? Plus 1. So it is plus 1 upon x plus 1. Okay, that is why there is no 2 here. Okay, Priyanka, Mohammed, have you understood? I just wrote over here for you to understand that there is nothing here, because here whatever is in the divisor, that I bring it down here, whatever I want to divide, and this is my divisor. But over here after x square there is nothing, so I can't bring down anything. So what happens here is minus x minus 1. So there is nothing. So 0 minus 1, which becomes plus 1, will give me plus 1. And that is why it is x plus x minus 1 upon plus 1 upon x plus 1. And that is why I have, when I am integrating x minus 1 dx plus integration of 1 upon x plus 1 dx. Okay, so it is just here or simply for your understanding I had written. There is no actually minus 1 over there, plus 1. So plus 1 plus 1 plus 2, there is nothing over here. I just wanted to tell you when there is nothing, it is 0 plus 1. So you have to write under alphabets, you have to write alphabets. Under the same par, you can write the same par. Okay, and that is why you get the same answer. Is that clear? You're getting the same answer because of this. Hope that is cleared. All doubts. Now the next we are doing is method of substitution. Like we had x plus 2 whole square. So there I use the formula a plus b whole square. I can do it. Now in this question, what is happening? I have to integrate 2x plus 3 raised to 7. I don't have this formula, I can use the formula, NCR formula, which you will be learning in the method of statistics. So you can use that and find also, no problem. But it is going to take a lot of time. Okay. And when the method of substitution is easier, we will use the method of substitution. When expansion method is easier, we will use expansion. If it is 2 to 3 terms, I can easily expand and then I can get the answer. But here it is 2x plus 3 raised to 7. So I'm using the method of substitution. And how do I decide whether I should use expansion or method of substitution? Just remember when the number of terms after expansion are small, okay, like a plus b whole square or a plus b whole cube. Use the formula, algebraic formula that you already know of, you've learned in your 10th and 12th standard, and then put it over there and quickly find the integration. But for this, even when you're using a plus b raised to n formula, then it becomes long because it's 7 terms. Okay, so I will simply use substitution. So what will I substitute? I will say put 2x plus 3 to be equal to t. Now differentiating on both sides with respect to x, what will I get? What is it? Will be, what will I get here? Derivative of 2x is, what is derivative of 2x? 2. And what is derivative of 3? 0. Okay. And what is derivative of t with respect? It will be dt. Okay. So 2 plus 0 dx is equal to dt. So 2 dx is equal to dt, or dx here, this dx I can write it as dx is equal to dt upon 2. Okay. So this becomes, now instead of 2x plus 3, what am I going to write? T. So this becomes, this is equal to integral of t raised to 7. Instead of dx, I am writing it as dt by 2. See, you can't in an integration or a differentiation write one term in x, another term in t. That is not possible. If I have to make the changes, I have to make it throughout. So here, instead of writing 2x plus 3, I am writing t. So instead of dx, I have to write dx in terms of dt. So this becomes integral of this. This is nothing but 1/2. I take it outside the integral. This is equal to 1/2 integral of t raised to 7 dt. Which formula am I using? Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So this will become, this is equal to 1/2. T raised to 7 plus 1 is 8 upon 8 plus c. Now 1 upon 2 into t raised to 8 upon 8. This is multiplication. So this is equal to t raised to 8 upon 16 plus c. Now I resubstitute. Okay, resubstitute. I get instead of t, I am going to write 2x plus 3 raised to 8 upon 16 plus c will be the answer. Okay, have you all understood this? So have you understood the method? Yes, Dipanshi, very good for pointing it out, right? Very good. So hope you have understood this example also. So in substitution, what have I done? Because the term is raised to 7, instead of expansion, I'm using the method of substitution. In the method of substitution, I'm using 2x plus 3 is equal to t, and then I differentiate this 2x is equal to 2x plus 3 is equal to t on both sides, and then I get 2 dx is equal to dt. So dx, I want to substitute not only for the x term, but I have to also substitute for the dx term. So in substitution, in method, remember that I have to substitute the term also, and I have also to substitute dx also. Now let us see this. Yes, Mayur, very good. You have learned this method in your 12th standard, but some of us have not taken mathematics in our 11th and 12th. So that is why we have to go very slowly, right? And the sums that we did in the 12th standard, those of you who have taken mathematics there, were sums where you have to solve, you have to prove that. Here it is MCQ. So you have to, even after finding the answer, make sure that what you found the answer is available in the 4 options. And if it is not available, just see whether you can rearrange your answer that you've got so that it matches with the answer available, right? Except when the answer itself is none of these, then it is a different thing. But other than that, like as I showed you, x raised to 3 by 2 you may have as an option, or you may have x root x as an option. Okay. Now here what happens is, I would like to simplify. So I will here, because in the denominator it is x square plus 1 whole cube. So when I expand this, the power in the denominator is more than the power in the numerator. I will not be able to divide actual division and do the sum. Okay, so that is why I am using the method of substitution. Because many of you ask, how do I know? Just see whether expansion is easy, do the expansion. Second thing is whether the division is easy, do the division. Now in this case, even the division is not possible because numerator power is less than the power in the denominator. ऐसे दिखने में लगता है x square plus 1, लेकिन it is raised to 3, तो actually highest power कितना हो जाएगा, x raised to 6, तो इसीलिए यहाँ पे वो यूज नहीं हो सकता. So we put, so put x square plus 1 to be equal to t. Differentiating on both sides. Okay. Derivative of x square is 2x dx. Derivative of 1 is 0, is equal to dt. So I have x dx to be equal to dt upon 2. Now in the numerator I have x cube. So integral of x cube. Now I need x dx. Now x cube I have, and I have dx. So instead of that, I write down as x square x dx. Okay. X cube I am writing as x square into x dx upon x square plus 1 whole cube. Now instead of x dx, what will I write? I will write it as dt by 2. Okay, instead of x square, how do I write it in terms of t? Let us see. Now x square plus 1 is equal to t. So x square will be equal to what? T minus 1. So instead of x square, I am going to write it as t minus 1. Understood? So in the numerator for x square, I am going to write it as t minus 1. X dx, I am going to write it as dt upon 2. And x square plus 1, I am writing it as here, t. So this becomes integral of, instead of x square, I am writing t minus 1. Instead of x dx, I am writing it as dt by 2. And in the denominator, what do I have? X square plus 1. Instead of that, I am writing it as t cube. Because x square plus 1 is t, so I am writing it. So this becomes 1 upon 2, because I don't need the number here. I am going to take it out of the integration side. 1 upon 2 integral of t minus 1 upon t cube dt. This can be written as 1/2 integral of t upon t cube minus 1/2 integral of 1 upon t cube dt. This is also dt. Now t upon t cube is what? 1 t will get cancelled. What will be left in the denominator? T square. So this becomes, this is equal to 1/2 integral of 1 upon t square dt minus 1/2 of integral of 1 upon t cube dt. Now what will I get over here? This is equal to 1/2 into t raised to minus 2. T raised to minus 2 plus 1 will be equal to t raised to minus 1 upon minus 1 minus 1/2. T raised to minus 3 will become t raised to minus 3 plus 1 upon t raised to upon minus 3 plus 1, that is minus 2. So this is equal to t raised to minus 2 upon minus 2. Okay, plus c. So what will I get the answer as? Okay, so this is nothing but, okay, let me write it over here. This is equal to minus 1 by 2, 1 upon t. And this is equal to minus, this is equal to minus 1 by 4. So minus into minus will become plus 1 upon t square plus c. So let me resubstitute for t. What is t? T is x minus t is x square plus 1. So let me put it over here. This will be equal to minus 1/2 1 upon x square plus 1 plus 1 by 4 1 upon x square plus 1 square plus c. Just a minute. So as you can see here that we are using this opportunity to solve the sums in as simple as method as we can. So here we have, oh, just a minute. Where did the file go? Okay, so here you have this way. Sometimes what happens is that instead of writing the minus sign in front, they will write the plus term. So this will be 1 upon 4, 1 upon x, this is 1 upon x square plus 1 whole square minus 1 upon 2 x square plus 1 plus c. Okay, is that clear? Jaspreet, you want me to explain again? Okay, fine. Just see what happens in this sum is, I'll just show it to be here. See, here what is happening? What is the power in the numerator? Okay, power in the numerator. Power of x in numerator is how much? 3, right? X cube. What is power of n in the denominator? See, this is x square and the whole thing cube. So you will have 6. Okay, you will have 6. So I'm not being able to use the division method because division numerator power should be more than the denominator. Then I can use the division method. And then, so what happens here is that I'm using the method of substitution. Now, what should I substitute? Usually we substitute something that is there in the denominator because it becomes easier for me to calculate. because x square plus 1 whole cube in the denominator becomes very difficult for me to solve in integration. And so because of that, I put x square plus 1, which is in the denominator, as equal to t. Then I get x dx is equal to dt by 2. Okay, this step, x dx is equal to dt by 2. Now what I should do is, now I have to rearrange. This step is very important. Okay, this step is very important. I rearrange the numerator, which is x cube. I arrange it as x square into x dx. Why like this? Because this is what I require, x dx. So I, instead of x dx, I will write it as dt by 2. Okay, so here I wrote it dt by 2, and instead of x square. Now what should I write for x square? You can see this arrow over here. X square plus 1 is t. So x square is equal to t minus 1. So instead of x square, I am writing t minus 1. Instead of x dx, I am writing it as dt by 2. And in the denominator, x square plus 1, I am writing it as t. So t cube. Okay. So once I have that, what should I do? My question becomes, this question now gets simplified to 1/2 t minus 1 upon t cube. So I divide t by t cube and minus 1 by t cube. T by t cube becomes t upon t square, 1 upon t square, and this becomes 1 upon t cube. And then I use the simple x raised to n, integration of x raised to n is equal to x raised to n plus 1 upon n plus 1. Clear? And then we are able to solve it. Okay, just breathe. Next steps are easy. The important steps are this: what I have to substitute, and second thing is, first step is deciding which formula I should, deciding which method I should use. For example, whether I have to do the actual division, whether I have to rearrange, or second, third, whether I have to substitute. Okay, so here I'm using the method of substitution, and then I have to rearrange. For x dx, that is an important step when I am rearranging the numerator x cube dx to be x square into x dx. That is the most important step here. Once I do that, I have to then decide which formula I have to use, and I get the answer. Clear, Jaspreet? So now we are going to move on to the method of partial fraction. All these sums now, once the class is over at night, after you have had your dinner, practice all these sums. Okay, whatever is there, the PPT is already uploaded. So just take those sums, try to solve them on your own, and if not, then you can go back to the video. No? You can check where you went wrong, what is the step that I should do, or which is the formula I should have used. Okay. Yes, good, you understood, right? Then we have the method of partial fraction. See, it is not necessary for you to remember the name of the method. That is the advantage, because you are doing multiple choice question. What is important here is that you use the correct method so that you get the answer in minimum number of steps in quickest time. Okay, so that is very important. So now we are using the method okay. Now in this method, what do we have? What happens is, sometimes I have 2 terms in the denominator, maybe even 3 terms in the denominator. So it becomes easier if I'm able to separate them. So once I separate them, I am able to find the integration of each of these separate terms. So here what is happening is, as you can see in this example, you have x minus 2 into x minus 3 in the denominator. Sometimes it may be like this, or sometimes you may, even get this, this 1 upon, it can be x squared minus 5x plus 6. Okay. So whenever like this also is there in the denominator, you can see it's a normal quadratic equation. And for that quadratic equation, I can easily find the roots. So this will give me as x minus 2 into x minus 3, which is the same as the given question. So you may sometimes even have like this in the denominator, and then also you have to use this method of partial fraction. So here what I do is, in the method of partial fraction, what is it says is that I will take whatever sum is given. So 3x plus 2 upon x minus 2 into x minus 3, right? This can be written as, this should be written as a upon x minus 2 plus b upon x minus 3. Okay. So I write this as a upon x minus 2 and b upon x minus 3. Why do I do that? Because I want to simplify this. Okay. I want to simplify this. So what I have done here is this. Now what I do here is, now I cross multiply. Understand this. I'm doing it very slowly. First step, identify whether or not I have to use the partial fraction method. And then when I have to use the partial fraction method, how do I write it? So I write a upon x minus 2 plus b upon x minus 3. This is the important step. Now once I cross multiply, what will happen? This is equal to a into x minus 3 plus b into x minus 2 upon x minus 2 into x minus 3. What do I have on the LHS? 3x plus 2, and denominator is x minus 2 into x minus 3, right? Denominator both are same. You can see denominator both are same. Now what will happen over here? This is equal to ax minus 3a plus bx minus 2b. bx minus 2b. And what do I have in the numerator on the LHS? 3x plus 2. Because denominators are same, I have eliminated them and I'm just writing I'm equating the numerator. Okay. So I'm equating the numerator. I have 3x plus 2 is equal to ax minus 3a plus bx minus 2b. Here what I have a term in x and I have a number. So let me rearrange. I take all the terms which contain x together and all the numbers together. So what will happen? This is equal to a plus b into x, right? A plus b into x minus 3a minus 2b. Okay. 3x plus 2 is equal to a plus bx minus 3a minus 2b. So equating the terms, I get 3 is equal to a plus b. Okay, because 3x plus 2 is equal to a plus b into x. So that means my a plus b should be equal to 3. So 3 is equal to a plus b and minus, and 2 is equal to minus 3a minus 2b. Minus 3a minus 2b. Now using this, can you find the values of a and b? This is simple. I have a simultaneous equation. Okay, you can write it like this. A plus b is equal to 3 minus 3a minus 2b is equal to 2. Multiplying equation 1. This is my equation 1 and this is my equation 2 by minus 3. What do I get? I get minus 3a minus 3b is equal to minus 9 and minus 3a minus 2b is equal to 2. I subtract, this becomes minus, becomes plus, this becomes plus, and this becomes minus. So what am I left with? I'm left with is minus b, right? Minus 3b plus 2b will become minus b is equal to minus 11, right? Minus 9, minus 2, minus 11. And so I get b to be equal to 11. If b is 11, what is the value of a? Can anybody tell me what will be the value of a? Simple? Yes? Because a plus b is equal to 3, if b is 11, what will be the value of a? Yes, very good. See, this is equal to minus 8. Because minus 8 plus 11 will give me 3. Now I have found the values of a and b. I can substitute over here. So this becomes equal to now b is not 12, Priyanka. Just check. Pushpa, we are taking A and B just because we want to simplify. You can take any alphabet. You can take X and Y also. But because already we are using X and Y, we avoid that. So we are using capital A and capital P. We just want to rearrange this number, this term that we have got, 3x plus 2 upon x minus 2 into x minus 3. We just want to rearrange it in such a way so that it becomes easy for me to calculate the integration. Okay, there is nothing, there is no reason why I'm using only A or B. I can use P and Q also. Okay, so this can now be written as, this is equal to integration of A upon x minus 2 dx plus integration of B upon x minus 3, right? Because that is what we tried to do here. We are writing 3x plus 2 upon x minus 2, x minus 3, a upon this plus b upon this. So now I have found the values of a and b. I have found the values of a and b. Dx can be written as integral of minus 8 upon x minus 2 plus integration of dx plus integration of 11 upon x minus 3 dx. So this is what minus 8 integral of 1 upon x minus 2 dx plus 11 integral of 1 upon x minus 3 dx. What is integral of 1 upon x dx? Is equal to log x. So this is equal to log of minus 8 log of x minus 2 plus 11 log of x minus 3 plus c. Now here you can even for c, okay, I'll just write it. In some books you will see that this c can be written as log c because it's just a constant. So I can write anything over here. So this becomes equal to 11 log of x minus 3 minus 8 log of x minus 2 plus log c. You may even write it like this. Okay. So in some books you may see this as like this, or you may even see it as simply c. So just if you go and see some book, don't get worried because it's just a constant. It is not going to affect your answer. The answer option will mostly concentrate on whether or not you've got 11 log x minus 3 and minus 8 log x minus 2. That is the most important thing. Pushpa, I hope you've understood. Yes, Archana, yes. Yes, I am. If there are factors in the denominator, it is easier for you to use a partial fraction method so that the solution becomes easy. And see, in the here in the first also you can see the power in the numerator is 1, x is raised to 1, and what is the power in the denominator? It is x raised to 2, right? Because it is x minus 2 into x minus 3. So x into x becomes x square. So that is why I cannot use the division method. So I am using the partial fraction method. Okay, Sayan? Dipanshu, integration by parts is also there in the syllabus, which I will be taking up today or maybe tomorrow, depending on the time that we have. Okay, so that will be taken up. Yes, I am the formula that are there on page 8.28 are the formula that we will be using. Dipanshi, what have you asked? How you have got this equation? A plus B. Okay. This is from here. 1 and 2, no? Dipanshi. I'll just show you over here. See, what happens is that on the left hand side, what do I have? I have 3x plus 2, right? And on the right hand side, wow, after I expanded this is a plus b into x minus 3a minus 2b. Now, for two terms to be equal, please pay attention, for two terms to be equal, all the terms in the x should match with all the terms on the left hand side, should match with all the terms of x on the right hand side. Okay, all the terms on the left hand side of x should match with all the terms in x on the right hand side. So I'll just write it in words so that you can have it in your notes. Equating terms in x, we get, what are the terms in x here? This is 3x and this is equal to a plus b into x, right? Here, because this term, this minus 3a minus 2b are constant. They have no terms in x. So we say 3 is equal to a plus b. Next is equating constant terms. Equating constant terms, we get, what is the constant term here? 2. And what is the constant term here? This is minus 3a minus 2b. Right? Why? Because there are no terms of x here. It is a and b are constant terms. So these two equations come from this. So this is my first equation and this is my second equation. Right? Hope that clears. I know, that is why I'm taking it slowly. If you have any other doubt, just get very clear. Is it so, Shambhavi? In study material, the number 8 is missing. Right. Very good. You pointed out. Just you can inform the institute also. There is the email ID. You can just let them know all the small printing mistakes. No? They as and when students or teachers find it out, we'll just inform them and they take it up to rectify the mistake. Very good. Yes, just breathe. Good, you've understood. Yeah. Chandan, have you understood? I have tried to explain again. Okay, so what happens in partial fraction method? You take what the question that is given and try to write it as an addition of two or more fractions. Okay, this happens why? Because in the denominator I have multiplication of many factors which I don't want in integration. It becomes very complicated. It is not that I can't do it, but it becomes complicated. To ease out the complication, what I do is I write it like this. Then 3x plus 2 upon x minus 2 into x minus 3, I get this. Now, what I do, I cross multiply. In this step, what I have done, I have cross multiplied. Okay, how do I get this? Cross multiplication. Okay, so x minus 2 into x minus 3. So this this is going to multiply by this, and this is going to multiply by this. So a into x minus 3 plus b into x minus 2 upon x minus 2 into x minus 3. Okay, and so I have, because the denominators in both this is equal to this, I don't talk about the denominator, I only talk about the numerator. And the numerator also I expand, I rearrange, then I equate all the terms in x together and I equate all the terms in y together, and I get this answer. Okay, then I'm able to simplify this given equation 3x plus 2, this becomes equal to this simple minus 8 upon x minus 2 dx plus 11 upon x minus 3 dx. Is that clear? And these are the formula you were talking about, Chandan. So these are the formula that we have. So sometimes you may have direct questions on this. Apart from the 6 formulas that we have done, Kami, you can attend the questions, the sessions on YouTube also. It is equally good because whatever we are talking, that is being recorded and put on the YouTube. So you will be able to understand. Any queries that you have, there is an email ID given on the BOS platform. Any questions you may have, you may send it to the BOS. Okay. Great. Now these are some of the formula that we have. That integration of dx upon x square minus a square is equal to 1 upon 2a log of x minus a upon x plus a. So that if I have, suppose I have been asked to form integration of 1 upon x square minus 9 dx. Okay, here you have to only be careful that it is a square. Okay, so this 9 is a square. So a is equal to a square is equal to 9. So a is equal to 3. That is the only thing, because we are in so hurry because you know the formula, and then and they will purposely put in the question with 9 in it. So make sure that you don't make that mistake. A square is 9, a is equal to 3. So if I have 1 upon x square minus 9 dx, so just write it over here. Integration of 1 upon x square minus 9 dx, this is equal to 1 upon 2, I say, a is how much? 3. So this is 1 upon 2 into 3, answer is 6. Log of x minus a. So x minus 3 upon x minus 3 upon x plus 3 plus c. Okay. So if I have this type of question, that is 1 upon x square minus 9 dx, so it is equal to 1 upon 6 log of x minus 3 upon x plus 3 plus c. The second formula that we have is dx upon a square minus x square. Dx upon a square minus x square is equal to 1 upon twice a log of a plus x upon a minus x. Appreciate these two formula. Here it is x square minus a square. The term of x is coming first and the term in a is a constant, is coming later. and 1 upon a is as it is, log of x minus a. So when I have this minus in the denominator, it is coming minus in the numerator here. Here it is a square minus x square, minus here it is coming plus here. Though you can do that, you can take the minus sign, okay? So that should not be a problem. But if this is the case, you have like this. So if I have the question, suppose I have the question, integration of 1 upon, say maybe 16 minus y square dy, and integration of dy upon 16 minus y square. Remember, here a square is equal to 16 and a is equal to 4. Just make sure that initially when you are practicing, write this down. I have seen students lose marks just because they made this silly mistake of taking a as 16. A is not 16, a is 4 here, because square root of a square will give me my a. So integral of dy 16 minus y square is equal to 1 upon twice a. So 1 upon 8 log of 4 plus x upon 4 minus x plus c. Okay. So you have this formula where you can take the formula, learn it, and then you can easily apply them. You have again two special formula for under root of x square plus a square and x square minus a square. So d by dx of x square plus a square is equal to log of x plus square root of x square plus a square, and d by dx of integral of 1 upon x square minus a square is equal to log of x plus square root of x square minus a square plus c. Okay. So for this also, I'll just give you an example. So here, what do I have here is, suppose I have a question. So let me take it a little up. Suppose I have a question, integration of dx upon square root of x square plus 25. What will this be equal to? Here, a square is equal to 25. Here, I don't need to calculate a. Okay, so because I have to directly use a square, and here also I'm using a square. So here there is no need. But in the earlier sums, okay, in the earlier sum where I have to use 1 upon twice a, so I'm using a singly. So there I need to write down. So this will be equal to integral of dx upon square root of x square plus 25 is equal to log of x plus square root of x square plus 25 plus c. Okay. So this is the way you have to do it. And same thing, if had the sum been minus, or had the sum been minus, it would have been integral of dx under root of x square minus 25 will give you log of x plus square root of x square plus minus 25 plus c. Okay. So simple formula that we have. So here what have we done? These four formula. Here what happens is we have x square minus a square in the denominator. Here we have a square minus x square in the denominator. Again, we have dx upon square root of x square minus a square or a square plus a square in the denominator. Now the next set of formula are when you have it in the numerator. Okay, when you have integration of square root of x square plus a square. Had it been simply square root of x dx, which formula do we use? I use x raised to n, integration of x raised to n. But here what is happening is it is square root of x square plus a square. So there is a function inside the square root sign. There is a function inside the square root sign. And for this is the bigger formula, that square root of integration of square root of x square plus a square is equal to x upon 2 square root of x square plus a square upon 2 log of x plus x square plus a square plus c. Okay. So here first term is x upon 2, second term is a square upon 2. This you remember, because this is simply the same that is given in the question. X upon 2 square root of x square plus a square upon 2 log of x plus x square plus a square. What happens when there is a minus sign inside the square root sign? It becomes x upon 2 x square minus a square upon 2 log of this x plus x square minus a square plus c. Okay, it's not necessarily that all these questions will be asked, so just do the simple ones first. You only have to learn this formula, because once the formula, if you know them, you can easily apply them. The sums, the initial formula sums, those if you are able to conquer, there is nothing like it. Okay, so you will be able to solve the sums and integration easily. Okay, I think we will do integration by part tomorrow, because it will take a lot of time, or on the second when I have this. See, you've asked when x and a both values are given. See, when both values are given, it will not be the question. Okay, just you're saying here in a is a constant. A is a constant. Okay, a is a constant and x is the variable whose integration we are trying to find out. Value of x is not given. Even when you are talking about definite integrals, it is the value of the range from where x goes, from 2. Okay, so x is something that is unknown or that is changing, and that is why you will not have something like 1 upon say maybe 16 minus 9. You don't do this. If you have this is simply dx upon 16 minus 9 is 7. Integration, suppose you have this is simply what? 1 upon 7 integral of 1 dx, which is equal to 1 upon 7 x dx. Is that clear? This is not where you have value of x. This formula is there when you have x square minus a square, and the a will have certain value. A will be 2, 3, 2.5, anything. Okay. But this is, you can't have that value of a is also given, value of x is also given, and then try to use this formula. Then you don't need this formula, right? If you have something like dx upon 16 minus 9, you will simply find out it is equal to 1 upon 7x, x upon 7. Okay. So this clarity I hope you've got now, that sometimes it happens because the questions are set that way. But for this, you will get direct questions where looking at the question, you will know where you have to use this formula. Mohammed, the modulus is given because you cannot find log of a negative number. So that is why the mod is just representative. Okay, that you need to take the positive value. Just let me tell you which sums. Let me just check with the exercise. Let me take it over here. Okay, like what you were talking about. So here what happens is, it is say 0 to 2. The x is always there. And in the last step, I substitute the value of x, and then see here I get x is equal to from 0 to 2. Is that clear? I'm just checking in the exercise whether you have these sums where you will be using these formulas. Okay, like in this sum, here you can see that 1 plus x square, here first you will be using the method of substitution, and then you will be, after you've solved it, then you will be putting in the values and using definite integrals. Okay. Okay. Yeah. So see here, you can find out. Here even, and also just one more thing, even if the sum is saying use a method of partial fraction, it is there for you to be able to do it easily. But if you find some other method easier, you can use any method, because it's an MCQ exam. So you can use any method and find the answer, so long as you get the correct answer, right? So I would recommend that you concentrate on the substitution method and method by parts, partial fraction method, and the method by parts that we are going to take up next time. So that instead of getting worried about whether this type of sum will come or not, as soon as the sum comes, you will be able to solve them. Okay. So that's all for today. Just work on it. I have taken it very slowly for you to be able to understand and appreciate all the various methods that we have in integration, and trying to do sums. So once you know, because in integration what happens is you have to use indices also, you have to remember the derivative also, because tomorrow when we do by parts, you will see that you have to even find the derivative when we are trying to use the integration formula, and that is why both of this you have to be very strong in to be able to get those marks. I hope you have understood this and have a wonderful day. I think there is 1 or 2 questions that you have put in for integration. I will be taking up tomorrow, right? So thank you all. Thank you for your patient hearing.